the High Efficiency Burner webinar here, co-sponsored today by Nicor Gas and Weishaupt, USA. My name is Bill Lewis, and I'm the Outreach Associate for the Nicor Gas Energy Efficiency Program. And sitting beside me is Norbert Heinrich, who is with Weishaupt America. And before we begin, I want to first of all apologize for the technical difficulties, but I certainly like to thank Weishaupt for sponsoring us today for this opportunity. They've been not only a gracious host, but they certainly have helped with promotion of the program and have been great contributors, so we thank them for this opportunity here. And I want to go ahead and we'll jump into the agenda for today. Basically, I'm going to spend a few minutes to cover the program, some of the monies that are available through the Nicor Gas Energy Efficiency Program. There are monies available for both the standard business program and the custom program, but because the topic today fits more within the custom, we'll spend a little bit more time on that. But there are monies available for all different types of measures here. And then I'll turn it over to Norbert, and he's going to dig a little bit deeper into different projects, different efficiencies. We'll let him handle the meat and potatoes of today. Before we get going, though, I want to do a little bit of housekeeping. Obviously, you guys are all on mute, so that's good. I appreciate that. As far as questions go, we'll have time afterwards for some questions. If there is something that's relevant to a particular slide that won't necessarily take us off on a tangent, feel free to chime in. Either mute yourself, or if you want to just shoot a little note in the box, we'll be watching that. But we will have a period, like I said, for questions and answers afterwards. We've scheduled this for about an hour. Given a little technical difficulties, we may run a little bit long, but hopefully we'll try to stick within that hour schedule. And we are recording this, and we will be sending this out to folks that register today. So you will be getting a copy of this. So if you miss anything along the way, certainly can catch up with that later. So that being said, let's go ahead and jump on in here. I think that for those of you that don't happen to know about the program, the Nicor Gas territory, as you can see here in green, covers about the northern third of the state here. It is a wide-ranging territory, and as long as you have your gas delivered by Nicor Gas, then you're involved with the program. For those that are maybe unaware of the details about the Nicor Gas Energy Efficiency Program, a lot of folks always ask us, where's this money coming from? Is it state money? Is it a grant? Is this Nicor money? And the answer is no. This is coming from the ratepayers. This is from you and I and everybody else that's getting their gas in the Nicor territory. There's a line item on everybody's gas bill. There's a prorated amount that everyone's paying into the program based upon their gas usage. If this is something you were unaware of, this may be a good opportunity to find out what you're paying into the program and maybe get some of that money back by doing some energy efficient upgrades. But we want to alert you to the fact that there is money being spent from the gas bill to pay for these programs, and so we encourage you to participate and try to get some of that money back. The program itself, Energy Efficiency Program, does have a calendar cycle, but ours starts in June. It's June 1st through May 31st for the projects, and at that point, the next program year begins and a new bucket of money is available. For this program cycle, all projects and applications have to be in by May 31st, or until money runs out, but I've been told that we do have enough to sustain us at the end of this year at least, so should be good on that front. For some of the standard projects, those that don't fall into the custom, we want to make a reminder that you have to see the application for the product within 90 days. Anything beyond that gets a little fuzzy from a program standpoint. So once you have installed energy efficient equipment, this is more appropriate for the standard side, but once you've installed that equipment, we do ask that you submit the application within those 90 days. Speaking of the standard program, I just want to touch on this briefly. Like I said, we're mostly concerned with the custom aspect of things, but standard, when we call it standard, the Business Energy Efficiency Rebate Program, basically, if you have old equipment and you're switching it out for new equipment on a one-to-one replacement basis, that's what this is designed for. There's a certain term savings that are attributed to each measure, and a corresponding rebate amount for each measure on the standard size. You can see what some of the common projects would be, both space and water heating. We do have commercial kitchens, look at steam traps, and obviously boiler tune-ups. Various industries are served with this, and we do have a list of all the different rebates available on our website, so feel free to look at that. Feel free to call us with any questions. Obviously, we can certainly help with any projects you might have, but like I said, we want to dig a little bit more into the custom side of things because that's where burner retrofits we find usually end up. So on the other side of the coin is the Business Custom Incentive Program, and that's kind of a catch-all for those therms that are not as readily identifiable, not standard equipment per se, but involves more of a process. And the benefit to that is that there are usually more therm savings in the custom programs and a little bit higher incentive dollars that are paid out. Now I say incentive because a lot of times we get into the incentive versus rebate question, and where that comes up is that the standard programs and standard projects you submit, you have up to 90 days after you've installed the equipment to receive your rebate, and it is a true rebate in that standpoint. But with the custom, that we call it an incentive because we do have to have a pre-approval done before any work commences. So the incentive is to draw folks out, make them look at the project, as opposed to just doing it and then trying to get money afterwards. We can determine that the project will save at least 2,500 therms. That's the entry point. And we have a little bit of a breakdown between the therms saved and the program here. You have to have at least 2,500, up to 7,500. That category there is paid out at 75 cents per therm, and anything that saves over 7,500 therms is paid out at $1 per therm for this program year, which again ends May 31st. We do have a cap on this, on the regular program of 500,000 or 50% of the project cost, and whichever comes first. Most of the projects that we see on the custom side, especially when inverters are involved, will be probably more in the $1 per therm saved, but again, it's going to vary project by project. And the reason we want to have a pre-approval submitted before the work begins, we want to make sure that the money that's available actually influenced the project or moved it forward. So it was something they were a customer was thinking about doing, but because there's money available, now we're definitely going to go through with it. That's kind of the intent of the whole program. Very briefly, the process is as follows. We'll get a project application submitted to the program. We'll have an engineer that's assigned to that project. There'll be some initial measurement and verification to establish the baseline of a project. Once we've established what that baseline is, and again, it's an estimate up front because we don't know what the actual energy savings is, but we try to take everything into consideration. We'll get the project in, the engineer will take a look at it, we'll set what the baseline is, and then we'll look at what is proposed to go in, and then we'll try to figure out what the energy savings is going to be, and then we'll base our dollar amount upon that proposed energy savings. Now, once the project is then begins, we'll have it go through till they have everything completed. We'll then send an engineer back out, and they will do some post-installation measurement and verification. And based upon what the actual measurements are, and they'll correspond it to what they did before they started the project, so that if they take a week worth of data, they'll take a week's worth of data afterwards. Once we find out what the actual energy savings is, that's what the incentive amount will be paid upon. Now we've seen different projects come in, and we've seen it go both ways. There are some times that there are some variables that come into play where the actual energy savings is a little bit lower than was previously calculated. That way, when you're ready to hit it, then we already have those stats, and we can send some free ridership. So that's the overview of the custom program. Some of the projects which Norbert's going to dig into a little bit more, but this is a list of some of the projects that may be familiar to you, or if you're thinking about doing any of these, would be something to consider. Lots of energy savings to be had, and lots of dollars to be gleaned for these projects. So if this is something that you're contemplating, we certainly would welcome projects and applications into the program. To kind of sweeten the pot a little bit, we are offering a bonus incentive to folks that bring in projects before our May 31st deadline. And here's some of the details about it. Anything that's new that comes in that started before January 15th, I'm sorry, started after January 15th, what is in and the application's in and the project is completed by May 31st, the program will pay the project down to an 18-month ROI up to $1 a therm. So right now with the $1 a therm being the highest you can get, this is basically doubled. But what they're going to try to do is figure out what's going to bring this project to that 18-month ROI with the cap of $2. So again, if folks are on the fence and they're thinking about doing something and they can pull the trigger on it and get everything in before May 31st, then so we'll sweeten the pot a little bit and make that happen. Now, if you had a project you have just recently submitted after January 15th, but before today, those will also be honored, and we'll also be looking at the 18-month pay down with a $2 cap. So keep that in mind for anything that may be on the books or could be a fast-moving project for you. And also up there, we are same sort of parameters, but we're looking at $1.50 a therm for the condensing rooftop units. That is also good through May 31st. And again, we just would look at what the baseline is versus the final savings, and then pay that out at $1.50 per therm. Some of the details of the bonus, the qualifications are at 25,000 therms. That is our baseline minimum to consider for the bonus. And like I said, it has to begin after January 15th and completed by May 31st. So again, if you're on the fence about something or you have something in the queue that you were thinking about maybe pulling the trigger on, hopefully this will kind of push you over the edge and see if we can move that forward. We are keeping the $500,000 cap per site in place, but the 50% project cost cap is being waived. So again, we're trying to make it as lucrative as possible and exciting as possible for those that may have those projects that are on the books or going to be on the books or they were thinking about. It is first come, first serve. There are limited funds here, so we certainly would encourage, if you're ready to pull the trigger, to jump into that. And we do set aside that money during the pre-approval process. So again, if you're thinking about doing it, we certainly would welcome an application into the program, and can get you guys going on that. I'm going to move along here, and next up will be Norbert Henrich, who's the general manager over here at Weishaupt, and he's going to dig a little bit more into the meat and potatoes of boiler burner efficiencies. Without further ado, jump in, and we'll let Norbert take over the controls from here.
Yes, thank you, Bill, and really appreciate the opportunity to spend a few minutes together here today and present from a burner standpoint a little bit of information that might help you consider a burner replacement project or looking at your burners in a boiler room, and take advantage of this wonderful program that Nicor offers for their customers to help reduce energy. So it's been a wonderful relationship with Nicor, and I really appreciate this continued process of working together. And let's look forward here the next 30 minutes maybe, and touch on some different aspects with energy efficiency from a burner boiler standpoint. As we go into that, we look at what the boiler population in North America currently is. Boiler population in North America is actually responsible for quite a bit of the energy consumption today's energy world. We're talking about almost 25% of the world's energy is consumed by the boilers in our buildings and our basements and commercial as well as industrial applications. When we look at this a little bit further, we find out that actually quite a few of the burner population, over about 60% of them, are older than 20 years. That means that they also lack quite a bit in efficiency, and oftentimes that efficiency is only between about 70 to 75%. So looking at the existing boiler market, there's quite a bit of energy savings possible by looking at some of that old boiler population and looking at ways to make it more efficient. There's quite a bit of energy savings available, equaling about 65 million, or actually 1 barrel of oil is 65 US dollars, and 26 billion US dollars are wasted every year. So there's quite a bit of potential for energy recovery here that's available by looking at this particular area. When we look at boiler efficiency, there's 3 different aspects that we would like to touch on today a little bit to help you understand where the monies are wasted and also how to actually go about maybe recovering some of this energy. Number 1 is efficiency losses in the boiler system. So we have a little illustration here to show you that. And it's quite interesting. The burner puts 100% of the energy into the system, but then afterwards only about, in our illustration here, only about 76% really become usable or are being transferred to the place where we want. And there are some losses, either radiation losses that transfer through from the vessel to the outside atmosphere, or a really large portion of the losses are stack gas losses. And of course, when we look at energy efficiency, we want to start at the place where the losses are the biggest. So stack gas losses would be the big segment here that we would look at. Radiation losses, that was the smaller portion in the previous illustration, could be attacked by potentially insulation of the boiler through boiler jacket or insulate pipes. That will help to eliminate radiation losses up to approximately 4%, and there's incentives available for that too. But as I mentioned before, where we want to really have a hard look at is at the stack gas losses, where we have approximately 20% and sometimes more that gets lost. Interestingly enough, about 30 to 48 degrees Fahrenheit equals about 1% in energy loss. So if we can reduce the stack gas temperature down, that means there are energy savings possible. And different technologies obviously out there for that, like economizers that will help reduce or help capture some of that energy that is in the stacks. But also combustion efficiency from a burner standpoint will help and aid in that particular regard. Another aspect as far as stack gas losses are concerned is also the turndown ratio of the burner equipment and certain behaviors as purging and boiler cycling, which we're going to touch on a little bit more as we move on here. This particular illustration shows us where the highest efficiency is actually located. So first, this might look a little bit confusing with all these different lines going everywhere. But what we want to kind of focus on is on the bottom, we have excess air and excess fuel. And the black line that goes upwards is the stoichiometric combustion. That would be oxygen about 0. And from there, we have the blue oxygen line going upward, signifying kind of the excess air that could happen in a combustion environment. Now, where we see the efficiency peak out and intersect with the blue oxygen line, we can see that right in that area is the highest possible efficiency in a boiler burner system. And that's where we want to focus on, and that's when we want to try to achieve, and where we want to be at with a good burner system is spend most of our time in that particular high efficiency area. We're going to look at that, jump just a little bit into some combustion efficiency theory. So here on the left side, we can see that for a certain amount of gas, so let's just call it 1 cubic foot of gas, there's about 10 times more air required to have a proper combustion process happen. That's a 1 to 10 ratio in the theoretical world. Now, there are obviously some factors that influence that, and that is outside air temperature, air pressure, the chamber pressure inside the boiler vessel, draft. You know, that can especially be a factor in Chicago when the winds are blowing across the lake. and fan contamination. So that would be just basic dirt and grime that gets pulled in with the combustion air into the system. So in order to compensate for that, we see on the right side, we add some excess air in order to compensate for these factors and add to the theoretically required air quantity about 15 to 20% excess air to cover those particular factors that are listed on the left. Anything beyond that really is adding additional air that has to be heated up in the boiler system, will go out of the stack unused, will not really participate in the combustion process, and increase our losses. That's why it contributes to those 20% that we looked at earlier. And as you see, the little note on the bottom in the box, there are some burners that use more than 100% excess air, so quite a bit of additional air moves through, and therefore that's a big factor of improvement that we can look at. So we have another slide to look a little bit, help to look at that a little bit more. So I just outlined that if we have gas, and ideally we add about 15% excess air to get good flue gas results, that would mean that our O2 content is somewhere around 3%, and our losses are somewhat low. Now, if your boiler system has 7% O2, so quite a bit more air, you actually end up having about 50% excess air. The quantity of combustion results is actually the same, but since you're putting more air in, you have more air going out, and that means you increase your heat loss in the system. On this particular graph, you can see, and you can combine that a little bit for yourself, or make a judgment yourself, looking at what kind of combustion results you might have in your own burner system. If you have 8% O2 in your burner system, you can see that you would have about 60% excess air. But oftentimes when we go out and we take some measurements on existing systems in order to try to figure out if this particular installation would be a good candidate for an energy efficiency measure, we quite often see percentages that are even higher than 8, even higher than 10, sometimes 12%, especially in the lower firing rates. And looking at this graph here, you can see at 12% O2, you're already putting about 120% excess air through the system versus the about 15 to 20% that would be required if you use a high-efficient burner system. So that is definitely something that we want to look at, and the first step certainly in the investigation process to determine if that's a good direction to go would be to do a tune-up on the burner system. And during the tune-up, we would obviously clean and service the burner, and your contractor would do that for you, and they would look at that, and they would be able to produce for you the best possible result that your current burner can have in the system. But there's certain limitations for certain burners, and we're going to look in oncoming slides about what a high-efficiency burner can do, and that gives you the opportunity to then compare it to what you currently have in your system and determine if that is a good way to go. Additionally, once the burner tune-up is done and you've kind of accomplished the best thing that you can with your system, what else can you consider? Where else can you go? Where else can you look for additional energy efficiency improvements? And that's where we want to, today in today's webinar, direct your attention a little bit stronger towards the burner. Could a burner retrofit maybe, or even a boiler changeout be the answer for you? And we have a few more things, the other 2 points that we want to look at from an efficiency standpoint, and then we'll hit on that particular topic of boiler versus burner retrofit and what the benefits in that direction can be. So the second thing we want to touch on as far as boiler burner efficiency goes is something that we call turndown ratio. The turndown ratio is very simply put the difference between the smallest flame that a burner can produce and the biggest flame that a burner can produce. And what that means effectively is any system that you have will have varying loads in the building. May it be because of the outside temperatures, may it because of some kind of demand from a kitchen or a laundry or something that might be in the building. And that causes the boiler system in the basement to have to either put more or less steam or heat out to the building. And consequently, then means that the burner has to work harder or lower. And depending on where that is, it could mean that a burner can stay on longer or cycle off more. We have another slide here that we can kind of show this in. So what you see here is on the left side is the turndown ratio, where you have a ratio of 4:1 versus 10:1 shown here in 2 lines. What does that exactly mean? Well, the difference between the high fire output and the low fire output builds the ratio. So let's say you have a 20 million BTU output on high fire, and you have a 5 million BTU output on low fire, then that would give you a 4:1 turndown ratio. If you had a 10:1 turndown ratio, that same 20 million would give you a 2 million BTU output. So now you see on the graph the arrow that shows you where the burner stops. And why did the burner stop at this particular point? Well, the load in the building at this point dropped below the 5 million BTU, and now the burner had no choice but to turn off. And as the load then creeped up above the 5 million BTU, then the burner had to start back on again. And you see shown in the very bottom of the screen that that typically then takes between purging the burner new and post-purging, all those things that the burner has to go through, about 2 minutes until you're ready to jump back into the system and actually produce heat. So if you vice versa had a 10:1 turndown, then the load would dip here, kind of like this, and go back up, and the whole time you would still be able to cover that with your burner. So your burner would just reduce its fire, keep tracking along, go back up as the system requires more output. And during that whole scenario, you really wouldn't have to have the burner stop, and you could save this particular purging cycles, which we want to now look a little bit more into. So what is a purge cycle? Well, during the purge cycle, anytime by code a burner starts, it has to blow air through the boiler system. And code requires that there is 4 air exchanges that have to happen during that time period. During those 4 air exchanges, all flammable gases that could be potentially still in the boiler system get purged and build a safe environment for the burner to start back up. However, what does that mean for you as a person that operates this equipment? It means you just spent a bunch of $100 bills to heat that vessel up, and now you're blowing cold air through it and cooling it back down. So that's another factor that decreases efficiency on a boiler vessel, because you're basically heating up air and sending it out the stack without really ever needing it or using it for anything. So in the next slide then we see another picture that kind of illustrates that again. So we purge air from a burner. The fan on the blower motor pushes the air that comes in at about 20 degrees Celsius, pushes it through a vessel that has more like 400 degrees inside. So it transfers that heat and sends it out. And So before it does that roughly, I would say about 60 seconds before it reaches that 4 air exchange ratio. Equally on a post-purge side, so anytime the burner shuts down, a lot of burner systems also have what we call a post-purge. In the post-purge situation, that can vary to sometimes 20 seconds that cold air is being blown through the boiler as well. We here at Weishaupt don't require that, and unless some local code requires it, we always turn post-purging off to make sure that we save that energy and retain that energy in the boiler system. The Department of Energy puts out a best practices guide, and here's a little snippet out of this best practices guide that refers to purge cycles. And it's shocking what kind of loss of energy can be produced by purge cycles. So here is where the relationship between turn down and purging comes together. So as we saw on some of the slides before, the less turn down I have, the more often my burner system has to turn on and off. And that's what we call cycling. So just with 2 cycles per hour, you can already have about 2% of energy loss that is unnecessary. With 5, 8%, with 10 cycles, even up to 30% in worst case scenario. So that really is something where big energy improvements can be made by looking at a high efficiency burner system that provides higher turn down ranges, and that is particularly true if your system, like many systems in our country, are oversized and spend most of their time in a low fire position. So again, what we just looked at, key factors for maximum efficiency are accurately sized equipment, regular tune-ups and service for maximum efficiency, the operating range or the turn-down ratio that we just talked about, and the excess air levels that we talked about as well. And you can see there are really only one point in those 4 that I just mentioned that we can overcome without changing the equipment, and that is to have regular tune-ups and make sure that the equipment brings the maximum efficiency that it is capable of. If we want to go beyond that and make maybe a correction to an oversized situation where the boiler maybe is now, because of some building envelope improvements or other improvements in the building, much too big now, that could be compensated with downsizing a burner, or certain things like the turn-down ratio or excess air levels, which we just highlighted in the previous slides, would also be tackled by looking at higher efficiency systems. Now, another aspect that we want to look at is the controls of the particular burner system. And there's a lot of talk been out there over the last few years over linkaged versus linkageless controls. What does that really mean and look like, and what are the benefits? Linkage controls, as we see them here in this picture, means that there's one common servo motor or stepping motor that operates or moves linkages to produce the firing rate, so moves between a lower and a higher firing rate. We call that modulating. But during this modulation process, this one servo motor actually moves several different areas. It moves the air damper, it moves the gas butterfly valve, and does so by using several pivot points and combining linkages to act on several different affecting points with one output. Linkageless control can do a much more accurate job in that, because what it does, it separates out the different action points, like shown here in this picture, the gas butterfly valve and the air damper, and act completely at that particular point with servo motors on that particular point. So you have one designated servo motor or fuel curve, and you have one designated air servo and the air curve. And you can program those individually from each other. That allows much more accuracy, and then results therefore in being able to capture the highest possible turndown and the lowest excess air that this particular burner system that these linkageless controls are installed on could possibly provide. What does that particular look at? I just want to spend a couple minutes on highlighting what that looks like in a high efficiency burner situation. So again, linkageless controls are a great measure to really get the most out of the burner. That's why at this time of point, Weishaupt really only sells burner with linkageless controls anymore, and we have redeveloped all our burners to incorporate these linkageless controls. And you can see that this servo motor sits exactly right on the shaft for the air damper. The air flows into here, moves forward, and then builds the flame up here. Likewise, the fully integrated gas butterfly valve sits right underneath the burner, is also equipped with a servo motor that is linked right to the shaft of the gas butterfly valve, and therefore allowing extremely accurate control of the fuel curve. Together with a very well-designed mixing head and a tight housing, this allows a very tight control of the combustion, and therefore these low excess air numbers that we talked about, and providing then a system that can run with only about 15 to 20% excess air through the complete combustion range. That means in low fire as well as in high fire, then resulting in maximum efficiencies. Looking at the burner head, the flame tube also builds a very strong component of a high efficiency system. And what we particularly do here is we have a burner design in which we keep the pressure drop in the combustion head constant. And you know, what does that mean in everyday language? That means that the turbulence that has to be created between air and fuel, because you know, a burner really is nothing else than a mixing device. It mixes air and fuel to make fire, and that process has to happen as efficiently as possible. And for that to happen as efficiently as possible, we need turbulence. As we run or modulate the burner into the lower firing rates, into the smaller flame, less air is required. And when less air is required, that automatically means less turbulence. So we can actually modify settings in our combustion heads that are also linked to an individual servo motor and builds its own curve by actually moving a sleeve that sits behind the diffuser backward and forward to close the gap in which the air can move through here and keep that turbulence active in front of the combustion head, therefore resulting in a nice 10-to-1 turn down while maintaining a low 3%, 3 to 3.5% O2 setting throughout the full firing range, and mixing the gas so well that the 0 ppm CO is the result, which the carbon monoxide is always a sign of unburned fuel or poor mixing of a burner system. Apart from that, always emissions are a factor, and emissions really doesn't have, or NOx, NOx, doesn't really have anything to do with the efficiency of the system per se. It doesn't have anything to do with your fuel savings or how much fuel you will use, but it is something that is considered, you know, by our government, that we want to have as many, as least as possible of these gases go into the atmosphere. So obviously, a good burner system also has to be capable of keeping those emission factors low, and that is available through different combustion heads. Okay, so we've now arrived, we've gone a little bit through the theory of combustion and what the different efficiency efficiency factors are. So let's spend the last few slides and the last remaining minutes on looking at some actual hard figures and some examples and see what can that mean in the future. In this particular slide, we have a comparison between a complete boiler changeout versus a burner changeout. And a little bit earlier, we were, asking ourselves the question, what else can we do? If the tune-up is not enough and it doesn't seem to really produce a lot of savings, what else, what can the next step be? Should the next step be replacing my boilers? And that could be a very expensive step. Or is there maybe another option? And where I would like to today kind of push your attention towards is to also have a look at the burner replacement. And we have here an example of how much it would cost, and of course these are just estimated numbers, to change out a, let's say, 500 horsepower fire tube system. A simple boiler burner package would cost somewhere around $200,000. To remove the old system and install the new boiler in a fairly normally accessible building, you would probably talk around $120,000. So to just kind of round it, it would be a $350,000 project for one boiler changeout. The efficiency gain we can estimate conservatively at 10%, which would mean your payback would take about 4 years to achieve. Now let's look at that from a burner standpoint. $350,000 is quite a capital investment, and it's usually quite difficult to get that passed through. But with a burner, we can reduce that cost down quite a bit. The equivalent burner in that about size segment is somewhere around $60,000 for a gas-only burner. Install that and removal and all the things that are included, estimate that at another $60,000 would bring us to about $120,000 for that energy efficiency measure. The efficiency gain, conservatively looked at, is about 7%, so not that far off the whole boiler package, which would immediately bring a payback that is much, much more favorable and somewhere in the 2-year direction. So definitely something worth looking at, and one thing I would like to bring your attention to is this particular example here doesn't even consider any help from energy efficiency programs like the Nicor Gas program. So that being considered as well could make this even more favorable or more interesting to look at. Now we have a few examples here that we would like to just showcase a little bit that have successfully taken advantage of these systems, and Nicor helped make that possible. And we have the Hinsdale Hospital, which has actually been in operation quite a while, and they're quite happy with the continued energy savings that they have. They have there a B&W water tube boiler that's built in the 70s and would normally require almost 40 million BTU burner input. For the need of the hospital or the situation at that time, that was oversized, and the current burner system that was installed on that boiler was able to only provide a 5-to-1 turn-down ratio. It also had pretty high excess air numbers of 7% and more, and frequent on-off cycles were something that the plant operators complained of. So after the retrofit, what was able to achieve was a little bit of a downsizing process took place. So the burner that was put on there was able to produce about 30+ million BTU. It was a high efficiency, high turn down burner that was able to provide the hospital with a 10-to-1 turn down ratio. The average O2 levels through the range were about 3.5%. One thing that was also very highly appreciated was an easy changeover between the oil to the gas. Just by the switch of a button, they were able to immediately go over from natural gas firing to oil firing, and that really also saves on time and the cost. Just the longer it takes you to switch over, when you have an issue, the worse it is in a hospital environment, obviously. What was really impressive was the fact that the estimated savings was estimated at about 6% savings, and the actual savings achieved was 11%. So this is one of those examples that Bill mentioned earlier, where the incentive was actually able to be increased during the process of the project, and the projected payback went from 3.8 years down to 2.4 years. And in the next slide, we can see the amazing check that Nicor provided for this project, and made everybody at the hospital extremely happy, and it was a fantastic project. Let's look at another project, Advocate Christ Medical Center. There, 2 water tube boilers were replaced. Burners were retrofitted on these B&W water tubes, so the water tubes themselves were not replaced, but the burners were replaced. Again, the turn-down ratio was significantly increased. The excess air was significantly reduced from about 50% excess air to 15 to 20% excess air. The savings were tremendous, over 100,000 therms per year for one burner, and that they were able to get from the Nicor Gas Efficiency Program were an incredible $180,000 for this project. Another project that was successfully completed was the Dow Chemical Process plant, where a Cleaver Brooks water tube was retrofitted. And it's kind of funny that all the projects that we're showcasing today, water tube boilers, that by no means that this is only doable in water tube boilers. Obviously also fire tube boilers and other boilers or heating systems can be looked at for these kind of savings. But again, over 100,000 therms saved per year, $76,000 in fuel cost reduction. The project received a $60,000 check for this measure. So also an incredible project, and there are many, many more in that particular area. So if that is something that would be interesting to you, I think it's certainly worth talking to Nicor about it. So in summary, what have we hit on today from as far as the factors for boiler efficiencies? We kind of combined this in 3 main factors. That is flue gas temperature, combustion efficiency, and turn-down ratio. A lot of these factors, at least 2 of those factors, are mainly burner-driven. So if you would like to improve your combustion efficiency and you would like to improve your turn-down ratio if your equipment runs very often in a low-fire situation, then looking at burner replacement might be a very good option. While you do that, you can also try to adjust potential sizing if your boiler is oversized currently. And I have to say, most of the projects I visit, at least 70% of the boilers that I've seen are oversized and run at low fire all the time. So those would be really, really good candidates. So in the next slide here, in summary, what are great candidates for a burner retrofit? They are boiler burner installations that have a high excess air level. So I would say at a minimum of 5%. This should be 5% O2, not 5% excess air. So if you're measuring 5% O2 or 8% O2 or even beyond 10% O2, then your system would be a good candidate to look at. If you have high run times, which means high therms usage per year, and I would say that would need to be at least 3,500 hours per year. If you have large load swings, which means your building load changes, you're not always running your equipment flat out, but a lot of the year you're actually maybe 60, 70% or lower, then your system is a good candidate to look at. And again, derating would provide an additional possibility of energy savings by making the equipment costs cheaper and also reducing some of the stack gas temperature that is associated with the higher firing rates. So again, if you have questions, now is a good time to let us know what we can maybe answer here. And then additionally, you have Bill's contact info right here that he will be able to answer any questions in regard to the energy efficiency program and the current incentives that are available. Thank you again for the time and for the opportunity for me to present this to you, and I'll hand over the mic to Bill here for the ending comments.
Very tentatively. Thank you very much, Norbert. Appreciate all that.